Let's go. We got Advent of Code 2023, day 15, Lens Library. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, Personal Protective Equipment Required Beyond This Point. As you step inside, you're immediately greeted by a somewhat panicked reindeer wearing goggles and loose-fitting hard hat. The reindeer leads you to the shelf of goggles and hard hats. You quickly find some that fit, and then further into the facility. At one point, you pass a button with a faint snout mark in the label Push for Help. No wonder you were loaded into that trebuchet so quickly. Does that point back to day one? It does. Look at that. You pass through a final set of doors surrounded with even more warning signs and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book entitled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the Holiday ASCII String Helper Algorithm, Appendix 1A. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm, haha, is a way to turn any string of characters into a single number in the range of 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character in the string starting from the beginning, determine the ASCII code of the current character, increase the current value by the ASCII code you just determined. Set the current value, current value starts at 0, okay. So we start at 0, we add the ASCII code, we multiply it by 17, and then we divide by 256. All right, so we can add it with 255. That's fine. After following these steps for each character in the string in order, the current value is the output of the hash algorithm. So to find the result of running the hash algorithm on the string hash, we do all these steps. Okay, I think I understand that. So the result of running a hash algorithm on the string hash is 52. The initialization sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore new line characters when parsing the initialization sequence. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization process. Ooh, okay. I've been waiting for like a virtual machine to come along, and this seems like it might be virtual machine related. PC equals 4. PC minus. This initialization sequence specifies 11 individual steps. The result of running the hash algorithm on each of these steps is as follows. This becomes 30, CM minus is 53, blah, 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 blah. In this example, the sum of these results is 1320. Unfortunately, the reindeer has stolen the page containing the expected verification number and is currently running around the facility with it excitedly. Run the hash algorithm on each step in the initialization sequence. What is the sum of the results? The initialization sequence is one long line. Be careful when copy pasting it. Okay, so that my puzzle input must be, okay. So let's get the input. It's going to be one giant line, which is going to defeat my get input program because it does a head, I typed 20 because I was about to say 20. It does a head 20 on the input. But if it's one long line, we're going to get the whole thing. Ready? Yep, that was one line. So we read one line of input. And that's a pretty big line. Wow. Okay. Very exciting. All right. So we have to split it by comma and then calculate the hash of each one and then add them all up. Okay, well that's, at least this part's going to be straightforward. 15. Let me start a new line here. 15. Tyrell 8, thank you for the follow. Welcome. Oh right, I forgot to do the this thing. Oh, no, I don't want to remove unused imports. Oh, 16 here. That's what I want to do. $23.15. And that should get us unsolved. Okay, so parsing is easy. Parsing is just, let's just stick them all in a vector. What are we calling these? Sequences. Initialization sequence is a common set related of steps. So we'll call them steps. Steps is a vec of string, let's say. So parsing is let lines equals, there's only one line, AOC lib, read lines, input 2023.15.text, and then self steps is equal to lines of 0 dot split on comma dot collect. And that should give us all of our initialization sequences. Oops, what did I miss? Can't be built. Oh, I have to two-string it. Right. Otherwise, we don't have allocations. And then we'll see how many there are. Self steps len. Oops. There we go. 4,000. Okay, so there's 4,000 steps. But this is not difficult, right? We can do is, since we're in Rust, let's write a little trait. I don't want to call it hash. I'll call it AOC hash. I don't want to call it hash because that would conflict with the actual hash. I want AOC hash of self returns AU8, right? Because everything is going to be 8. And then we'll say impl AOC hash for string. AOC hash self U8. Oh, you know, that might I might have made it more difficult for myself than I need to. Let's make it usize. I was thinking you could just do everything in U8, but we can't, right? Because we're going to multiply and we're going to go beyond U8. So we have to use something bigger. So we just say self chars fold 0 ac character, and it's going to be character as usize plus ACC, all of that multiplied by 17. Oops. Right? We multiply, we add character to the thing, we multiply by 17, and then we mod by 256. And I think, I've got a feeling the optimizer will convert %256 into a bitwise AND. All right, is that it? And we just need to sum them up. Iter map. I wonder if I can do the AOC hash like this. Sum usize. If not, I'll just do a fold. Can't. That would have been nice, because I do have AOC hash trait for string, and these are strings. So, but that's right. What we'll do now is instead fold 0 ac step ac plus step yeah, we're just adding them up. Yeah, okay, we don't have to AND this one, right? Oops, doesn't like that. Oh, I should do a reference, right? Here, 515210. Scoop says impl for stir, make it more flexible. And FastByte says we can go with U8 and use wrapping, add mult, so 256 operations not needed. Oh, that's a good point. I'll have to try that. Let me get this one done and do part 2, and then we can fiddle around. Ooh, good. That's the right answer. That's good news. Okay. That was fast. All right, part 2. You convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of 256 boxes, numbered 0 through 255. The boxes are arranged in a line, starting from the point where light enters the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Uh-oh. So I guess we're not implementing a VM. And I wonder if we're going to have to take into account. Is this the Chinese remainder thing, where each one is going to start at a different location and figure out when the light passes through? Although light's fast, right? Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. Okay, so you have boxes. Every box has a lens slot. Several lens slots. Okay. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall running parallel to the boxes is a large library containing lenses organized by focal length ranging from 1 to 9. The reindeer also brings you a small handheld label printer. Okay. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or hash map for short. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm on the label indicates the correct box for that step. Each step begins with a sequence of letters that indicate the label. Okay, yeah, so we saw that before, right? Starts with the sequence of letters. Label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. Okay, so we're kind of doing a VM-like thing. This might be fun. If the operation character is a dash, go to the relevant box and remove the lens with the given label if it is present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. No lens in that box is a given label, nothing happens. Okay. If the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there is already a lens in the box with the same label, replace the old lens with the new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. I assume the new lens now gets the label. Okay. If there's not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Okay. That's fine. I think that's just a vec push. And this is a vec. Oh, I don't know if vec has replaced, but we can intermute over vec. Here's the contents of every box after each step in the example initialization sequence above. Rn equals 1. Okay, so the way we determine what box we go to is using the hash algorithm. Yes, the result of running the hash algorithm on the label indicates the correct box for that step. Okay, so Rn will always go in box 0. But equals 1 means we use focal length 1 in there. CM minus means go to whatever box CM is in and remove it, but there isn't one. QP3, so that goes in box 1. CM2, oh, CM goes in box 0. QP minus means remove QP from box 1. PC4, put lens 4 in box 3 labeled PC. I believe I'm understanding. OT equals 9, so then it goes after that. AB equals 5, it goes after that. PC minus, remove PC and shift everything down. Okay, so yeah, it's just vec remove, right? And these are vec push. PC equals 6, so PC now goes at the end with focal length 6. OT equals 7. Oh, okay, so here we just changed 9 to 7. So we can do a find, right? We can get the position of OT. If there isn't an OT, then we put it at the end. If there is an OT, then we have to update its value. All 256 boxes are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from the front to back. Each lens is shown as its label and focal length in square brackets. I understand. To confirm that all the lenses are installed correctly, add up the focusing power of all the lenses. Focusing power is a single lens is the result of multiplying together 1 plus the box number of the lens in question. That's eliminating box 0, right? The slot number of the lens within the box, 1 for the first lens, 2 for the second lens, and so on. And then the focal length of the lens. So that's the little number we store in here. So we multiply all those 3, and then we sum them. Yeah, add up the focusing power. What is the focusing power of the resulting lens configuration? That's what we're looking for, with the help of an overenthusiastic reindeer in a hard hat. All right. Let me commit this change first, since I never did. Git status, git add source, git commit, -m 2023, day 15, part 1. All right, so what we can do is create a little lens. This might be overkill with a label and a focal length. I'm picking U size. I'm assuming that these are all going to be positive numbers. Didn't it say, actually, it said 1 to 9 or something like that? Yeah, 1 to 9. Okay. So it could be a byte. Scoop says 1 to 9. Yep. Okay. So what we can do, we'll create a boxes. Which is going to be a vec of vecs of lenses. And we're going to create 256 of them. 1 for each box. Ooh, I might have to specify that, right? Do I have to do that? Like vec of lens? Nope, doesn't like that. The trade copy is not implemented. Oh, I have to implement copy for this thing? I'm fine with that. Oh, it can't be implemented for strings. Dang it. But can I do clone? It still needs copy for this. Okay, maybe this is overkill then. Can we do this? String usize. Nope. Scoop says standard array from function. Do I need to specify anything in here? Yeah. Oh, I think I'm trying to do it this way, right? Yeah, and now I can specify the T, vec of lens. I'll put the lens back. Struct lens, label, string, focal length, usize. Can this work? Trait clone. See, now I just need clone. Oh, which doesn't work for string. No, it does. Okay. It's copy that doesn't work for string. Okay. I think we're there. Scoop says boxes vec lens is standard array from function. Oh, okay. I've never tried that before. Let's try that. This works, but we can do it this. I'm going to try it Scoop's way. So we specify the type being this, and then say standard array from fn. And that takes a constant n of usize. So I have to specify that, and I just specify the type. But the type is already there, right? Okay. That's an interesting way. This seems a little shorter to me, but it's good to know this as a possibility. So I'll keep that in my toolbox. Luminox, thank you for the follow. Welcome. All right. So now we're going to just loop over every step for step in self steps. We're going to split this thing up. It's either going to be something something equals something or something something minus. So we can do this way, right? We can say if let sum label focal length equals step split once on equal sign. Then we're going to handle, actually what I'll do is println label gets focal length. There's 4,000 of these, so it's going to take a while for Bacon to gather up all the data. Length. Else if let sum label nothing is equal to step split once on minus, then println let's just say removing lens label. Otherwise we have a panic bug in code, can't read step. There we go. How's that? Let's see what this generates. It generates failures. Oh, right, because I didn't put these in. These are meant to be tuples. Like that. Scoop says step strip suffix dash. Yeah, but how would I know if that succeeded? Right? If I say step strip suffix, what does that return? It returns an option string. It returns a string slice with the suffix removed. The string ends with the pattern suffix, returns a substring before the suffix wrapped in sum. String does not, it returns none. Okay, that's good to know. Let's do that. Strip suffix. What did I mess up? Oh, I was doing that. Okay. Okay. So removing lens SHN, removing lens HBL, label LZ gets focal length 3, and so on. So we can have 4,000 of these suckers to deal with. Okay. This doesn't seem like it's going to be that complicated. I just want to take a look at the input again. Is it still up here? Yeah. So SHN, yeah. So that's what it said, right? SHN removing, HBL removing, SDJK, and then LZ3. So I think we're parsing it correctly, right? Let's go back here. And now we need to figure this out. We need to figure out the box. Oh, no, can't use box. Index is equal to label.aoc hash, right? So we hash the label part, and that tells us which box to go into. And now each box has a vector that we need to look through. Let position is equal to boxes of index dot iter. Do I have to do that first? And then position of lens, where lens dot label is equal to label. We can say if let sum pos, right? If we find it, actually I want to iter mute because I need to change it. It's interesting. We're at 97 there. Okay, I'm going to make this thing a little bit wider so I can see everything. So this should give us the position of, oh, it's saying unknown. else boxes index dot push lens label focal length focal length dot parse unwrap. Right, we're going to stick the lens in there. Oh, label to string. Scoop says you want find, not position, and find gives you the entry, not the index. Oh yeah, I was just going to use boxes of index position, index position. But you're right. If we get the entry directly, then we don't have to worry about that. It still says unknown. Lens dot pattern not found. Oh, right. Yeah, this was the thing where you were recommending this. Changing it to string so it works for both ways. Lens does not implement debug. Let's add that. And AOC hash not found in ampersand string. Oh, see? That's not helpful. That's not helpful at all. Why wouldn't that work for regular string? Label is a reference to a stir, so I should be able to do that. Oh, I broke part 1. That's it. Oh, okay, so this doesn't work for string. I mean, I can get this working again just saying as stir, right? Yeah. So at least part 1's working again, but it'd be nice to be able to have it just work both ways. Maybe there's some other kind of trait I can stick here that'll allow it to work both ways. Okay, we got this. And now we're not printing out anything. Because we should be finding something. Yeah, okay, here. XN is the first one where we found, and it has a focal length of 4. If we look for XN, we should have put 1 in. Oh, no, this is removing. So I guess I should say inserting. Inserting label at focal length. And what I should do is make a lens constructor. Yeah, so inserting LZ here and lens label FSRMB. It's getting a new focal length. Let's see if we can find this. Yeah. So it found the one with the focal length 4 and it just needs to update it to length, right? Updating to 4. Okay, so here's one that's different. The others are the same. Why are they the same? This changing 4 to 4, changing 7 to 8. Okay. So now we actually have to do the other work. We don't need that line anymore. So now that we have lens should be a mutable reference to a lens. So we should be able to say lens.focal length is equal to focal length parse.unwrap, which I should just be able to do here because I need it. Focal length equals focal. Come on. There we go. Parse unwrap. Just do that once. And then we can do that. And then we can do that. Type usize can't be dereferenced. Oh, look at that. Okay. So now removing. Now we do want to find the position in the box that we're boxing. So we still need this. Right? We still need to get the index. Scoop says impl IOC hash for asref stir. Yeah, let's try that after I get part 2 done. And you're also recommending using retain. Let's use retain. So we can say boxes of index dot iter. So retain, do I have to reassign it back to the box? Why is that? Oh, is that on vec itself? Yeah, okay. Retains only the elements specified by the predicate. Okay. So x, where x, when it's a lens, where lens dot label is not equal to label. Right? Okay. So that did that. And now we need to, oh, we have to add up all the stuff. Okay. So this is going to be self, steps, no, boxes. We're going to iterate over the boxes. Iter, map, what's the rule? Oh, it's the box we're in, so we're going to enumerate. We have to add 1 to that. And then within each one, we're going to have a number of lenses. So this is going to be lens list, right? Which is should be a vec of lenses, right? With this thing. So let's actually do that. Box number, lens list. All right, so that's the vec of lenses, and this is the box we're in. And so now we have to map lens list, iter, enumerate, right? Because we need to know the slot it's in. So that's why we're going to enumerate a second time. We're going to map that on slot and lens. And now we can finally calculate. It's going to be box number plus 1 times the slot plus 1 times the lens's focal length. No, it doesn't like that. Oh, because it's a tuple. There we go. Lens's focal length. Right? And now we've finished that map. We have to sum these up, right? Is that what we're doing? We're just summing everything up? Yep. Sum usize. And then we're done with that map, and we have to sum that up. And then we're done with all of that. Let's see what formats to. Okay. Is this readable, or should I just do a double for loop? Let's see if this is right. And if this fails, then I'll do a double for. Hey, that's the right answer. Wow. That was fast. Very short day today, huh? Not bad. 1745, is that the soonest? No, day 1 was 1727. Okay, or 727. Is that the second best? Nope. Here, day 4 was even better. Day 2 was even better. Okay, never mind. Never mind. It was a quick recent one. All right, the last faster one was 11. So, okay. Never mind. Goldmonk says, congratulations. Scoop says, first shot both times. Yeah, sometimes you get lucky that way. Sometimes you fail to make mistakes that you normally make. Let's take a look at the calendar. Okay, so I think, yeah, is this all filled in essentially? We're going to maybe go back to Gear Island. I don't know where the next star is. Oh, Sorry, no, I should be looking here. This is going to be the next star inside this mountain. All right. All right. What was I going to do? There were a couple of things I wanted to try doing differently. Oh, right. The recommendation from before was to, instead of doing this mod 256, we could just do a wrapping add and a wrapping multiply. And that way we eliminate the thing. This would then, right, we could say this wrapping add of ACC, and then a wrapping multiply, right, of 17. Let's see if this gives us the same numbers. I'm going to have to cast it as usize. Lamp Web Dev, thank you for the follow. Welcome. Yeah, it gives us the same numbers. It's a little more wordy, but it avoids the mod, as somebody said. Lamp says, hey, I found your videos on YouTube and finally could make it to a live stream. Well, I'm glad you're here. Welcome. Glad you enjoy my YouTube videos. I still have to finish editing 13 and 14 and now 15, so I'm way behind on that. All right, so we did this. This isn't too bad. It's a little less legible, I think, than if we do it just this way, right? And it gives us the same answer. Says, I was stuck on day 4 because of Rust, and that video helped me. Oh, good. I'm glad. What was day 4? Day 4 was scratch cards. Oh, yeah, I remember that. Yeah, I just used intersection, right? That was fun. This was fun. Today's was fun, too. It was very short, so we have a short stream today. Oh, yeah, this was the other thing, is we could either do boxes this way, or we could do this from function. And from function vec new is kind of an overpowered hammer, right? Whereas if we just use vec, and the macro will just generate the 256 new calls. I don't know which one's more efficient, but I don't think we're worried about efficiency. Oh, right, the other thing I wanted to do was see if I could fix this as ref stir. Let's see. Add din. Okay. Let's try that. T as ref stir for T. I just need something that can iterate chars, right? That's all we need. I don't know if chars, if there's a generic trait. Oh yeah, and then we have to throw a lifetime in there. Method cannot be called on stir just to unsatisfied trait bounds. Oh, okay. It's saying I shouldn't have to have. Wow, this is getting more and more complicated by the second. Sized. It's saying it shouldn't have to be sized. It still doesn't like it. Why not? Oh, you're saying I don't even need the reference. I could just use stir on its own. I don't normally do that. By default, my brain automatically goes to. But you're right, because this is the ref. It still wants me to do that. Okay, I can do that, or I can do it with the thing. Yeah. Let's try it with the T. T as ref stir. We'll see if we can eliminate the din. No, see, there's no method on chars in that, right? It needs something that implements chars. Stir does. Oh, okay. Yes. This was in, thank you, Scoops, again. This was in Rustlings, I think, and I should have remembered it from that. Yeah, so you have to grab the ref that you're going. So I should be able to, hopefully, eliminate that. Yes, 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 this is good. And where else do I use AOC hash? Right there, and it's just use it directly, perfect. That's it. All right, so that did it. Yeah, okay, so I'm just gonna have to remember that when I do the as ref, I should take the ref, and then I'll get the thing that I'm looking for. All right, that's pretty clean. That's pretty clean. The only other thing would be nice to do is generate, and since I have time, it's not even 8 o'clock yet. We can generate a command rather than doing all this wacky stuff. Let's do this enum command or step, right? And one of them is going to be replace lens string usize and remove, I guess just replace is sufficient, remove string, right? And then we can say impl from stir for step and separate out all the logic that up here, right? So we can do this. If this is true, then we're going to return a self replace label focal length dot parse dot unwrap, right? Otherwise, let's label the toString, right? Because I think it's a stir. It's an unknown because we need to yes. Yeah, stir. Okay, so I'm label toString. Nope, doing the wrong thing. Some label equals s dot, what is it, strip suffix, right? Self remove label toString. Except I have to not type a remove, else panic cannot parse s, right? And now up here, we can do this. We can say match no, we can say let command equals colon step equals step parse unwrap match command and then we want to fill in the match arms here. Right? This, yeah, it's a step. So why is this not? Oh, because I typoed it. There we go. Fill match arms. So in replace, it's this. Scoop says you have an error value. Use it. Yeah, but then I don't see a panic string. I guess I could just make it a string, right? And then this business here. Boxes index, intermute, find lens, word lens. Oh, why is this not finding the lens now? It doesn't know the lens type. Boxes is my vec of lenses. Index is index is unknown because label focal length. There we go. Now I figured it all out. There we go. And then remove is just label. We can just move this. Right? And then this goes away. All right, let's change this to a string, and we can just say error string. And then we can say error format bang cannot parse s. How's that? Or should I go to, oh yeah, these need to be okays. Like that. And I deleted the semicolon for some reason. All right, and look at that, it's the same answer. So this puts all the parsing logic down here, and we can just use the actual logic of what we're supposed to be doing based on what the command is. How's that? Is that a nice clean solution? Scoop says clean. Excellent. Yeah, I can live with this. The only other thing is, oh no, I was going to say, well, we could, doing the parsing step, we could do it, but we can't because we need the actual full string to do the parsing. I mean, to do the part one. All right, and I'll leave this like this because this is a good way to remind myself about the existence of this thing. This is still a little messy. Okay, so there's only one other thing I want to do before I finish, since I still have time. Impl lens fn new. Ooh, we can do this, right? Right, lens, oh, label, s, focal length, U size, self. Let's see if I got it right. Label is label to string, and focal length. Nope. Oh, this has to implement display. Okay, let's call it D. There. We're not using it yet, but let's use it up here. That's the reason I was doing it. So say lens new, label focal length. Hey, there we go. That's a little bit even cleaner. And the only other thing is this duplicated code here where we're calculating the index twice. But we can't, well, we could stick it in the lens. No, this is fine. This is fine. Enough fiddling around.